Good day, welcome to another video where we are doing the final video on our test or exam preparation series on our sequences and series. Okay, so here we have question 2 and question 3. So we'll begin with question 2. Okay, so question 2, we're given a quadratic sequence of which they say write down the next term of the sequence. So 2.1.1, we know we have 2, 3, 10, 23 all the way, right? Of which here we know these are the difference is 1, the difference is 7, the difference is 13. So the difference here will be 19 every time we add 6 more, right? So T5 will be equals to 23 plus 19, which is equals to 42, okay? Then 2.1.2, they say determine the nth term of the sequence. So we know Tn is equals to what? An squared plus Bn plus C, right? Of which here we're given a pattern, 23, okay? And from this we know we have 1, 7, 13, and then we have 6 and 6, right? There's a common difference. So yeah, here we have 2a, and then here we have 3a plus b, and then here we have a plus b plus c. And let's note down that this is the quadratic, then this is the arithmetic, and then this is the common difference, right? Common diff. And then from this we know 2a is equals to 6, and then our a is 3, dividing both sides by 2, and then 3a plus b is equals to 1. Then you say 3 in bracket 3 plus b is equals to 1, therefore b becomes negative 8, right? And then a plus b plus c is equals to 2, right? And then from that we get 3 plus in bracket negative 8 plus c equals to 2. Therefore c becomes what? Becomes 2 plus 8 minus 3, which is 7. Therefore Tn is equals to 3n squared minus 8n plus 7, right? And so we're done with 2.1.2, and then 2.1.3, they say calculate the 20th term of the sequence. So here we just have to substitute 20. So this is 20 squared minus 8 in bracket 20 plus 7. So let's see what this gives us. Okay, this gives us 1047. So we are done with question 2.1. And then question 2.2, they say calculate, given the arithmetic sequence 35, 28, 21, calculate which term of the sequence will have a value of negative 140. So, okay, for us to do this, first we'll have to actually calculate the general formula, right, for an arithmetic sequence. But then what they're basically asking is what Tn, when is Tn basically equals to negative 140? This is the question for calculate which term. So basically they're asking which n will give us negative 140. Okay, so we have 35 and then 28, we have 21, right? Of which we know there's a common difference, of which the difference is 28 minus 35, right, which is equals to negative 7. And then from that we obviously use the general formula derivation, of which we have a plus n minus 1 d. We know the first term is 35 plus n minus 1 and then negative 7. Here we have 35 minus 7n plus 7. This gives us negative 7n plus 42. You may substitute the first term just to verify if the formula is correct. Okay. Okay, so but then the question was asking for what, which Tn is negative 140. So here we therefore have to say negative 140, which is basically the Tn value, right? Now we want the respective term number, which is negative 140 equals negative 7n plus 42. And then from this, you can say therefore negative 182 is equals to negative 7n. Divide both sides by negative 7. You end up with n being equals to, okay, let me calculate 182 over 7. N being equals to 26. Kindly note that whichever term you find here, it must be a whole number, right? Yeah, it must be something like 26 or 27 or 28. You should not find decimals. Yeah, should you find decimals, just know that your formula right here is not correct. Okay. Yeah, and then question 2.3, they say, for which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? Okay. Let's read this once again. So what are they asking for here? They saying to us 2.3, for which value of n will the sum of the first n terms of the arithmetic sequence? We know they're speaking about what? Sn n over 2, 2a plus n minus 1, right? Okay. In question 2.2, right, that we derived, be equal to the nth term of the quadratic sequence in question 2.1. You see, so for 2.1, they're speaking about the quadratic sequence equation that we derive, but not the summation thereof. So they're asking, when will this be equals to? The quadratic one we had found 3n squared minus 8n plus 7. So they're asking, when will this sum be equal to this equation right here for the quadratic? That is what they're asking in mathematical when you convert it into a formula. So here you end up with what? You end up with n over 2. What was our a? Our a we know is 35, right? Plus n minus 1. Okay. And then the common difference, you know, it was negative 7. And then here we just leave it as 3n squared minus 8n plus 7. Right, and then let's multiply both sides by 2. Okay. So here we end up with what? This will be n, and then inside the brackets, we're going to have 70 minus 70n plus 7. And then here we're going to have 6n squared minus 16n plus 14, right? Of which here we end up with not 70, this is 77. 77n minus 7n squared, which is equals to 6n squared minus 16n plus 14, right? Of which from this we can move everything to the right hand side to end up with 0 being equals to 13n squared minus 16 plus 77, 93, and then plus 14, right? Of which here we have the factors, everything all equals to 0, 13n, and then we put n here. We need factors of 14 that are gonna help us to achieve negative 93. So that is actually 7 and 2, both negative. And then therefore we say 13n minus 2 equals to 0, or n minus 7 is equals to 0, of which from this we therefore get that 13n is equals to 2, of which n is equals to 2 over 13, or this side n is equals to 7. So we know that actually we cannot have a term number that is n over 13, right? As I said earlier on, it has to be a whole number, right? So this one is not applicable, right? Therefore, n is equals to what? N is equals to 7. So that is term number 7. You can substitute back right here. You can substitute back here and substitute back here as well and see what you get. Let me highlight it. Now using another card, you can substitute into this equation and see what you get for 7 and substitute here to prove it. Okay, so now let's move to our question 3. Okay, so question 3, we are given a geometric series that has a constant ratio of half and a sum to infinity of 6. And then 3.1, they say calculate the first term of the series. So 3.1, first term of the series, we're given r as half, and then s infinity we know is equals to 6. Okay, and then first term of the series, basically it will be what? We know s infinity is equals to a over 1 minus r, right? Of which we know this is 6 as given, and then a, and then 1 minus, we know a is the first term, right? A is basically t1. 1 minus, what is the ratio that we're given? It is half. Okay, so, and I prefer that you put it in bracket all the time in case maybe it was negative, to not end up forgetting the negative. Okay, so here we end up with basically 6 times half, right? Of which therefore our a is equals to 3, right? Our a becomes 3, which is our first term. And then we can even say it down, therefore equals to 3. And then they say calculate the 8th term of the series. 3.2 T8, they're asking for T8. But then we know that Tn is equals to, is basically 8 times r to the exponent n minus 1, right? Of which our a, what is our a? Our a, we determined it as 3 times the ratio. The ratio is given as half, and then n to the minus 1. Therefore, T8 will be equals to 3 times half to the exponent 8 minus 1, right? And then 3 times in bracket half to the exponent 7, basically. Here we get 3 over 128. Okay, so this is actually the same as T8 being equals to 3 times half to the exponent 7, right? It is basically a r to the exponent 7. Okay, I've spoken about this in the previous video. You may go and watch it out. And then okay, now we move to 3.3. 3.3, they say given us the sum of a geometric sequence starting from k being equals to 1 all the way to n, which has a formula 3 times n to the exponent 1 minus k is equal to 5.8125. Calculate the value of n. Okay, so 3.3, we know that k begins from 1 and then it goes all the way to n, right, which is the last value. And then we know that our Tn is equals to 3 in bracket 2 to the exponent 1 minus k, right? Of which, okay, for us to calculate the value of n, And one thing that we also given as well that I have to highlight is that Sn is equals to 5.8125, right? And why am I saying that? We know that Sn basically, as you might have seen in my previous video, Sn is equals to K1 and 3 2 to the exponent 1 minus K, right? It's the same thing. Okay, so from that, calculate the value of N. Okay, let me just remove that. Okay, so here let's continue. Calculate the value of K. One thing that we do, the value of N, one thing that we have to note, guys, is what? Note this part here, this part in your 2 to the exponent 1 minus K, which is actually the R part, right? This is a sorry, no. But anyways, this is the R part, ne? This is the R part that we have here. But yeah, as for A, let's leave that one out. But the 2 to the exponent 1 minus K is the R part. So this basically is the same as what? Over 2 over K, right? Of which you will notice that every time this will basically give you 2 over 2, and then 2 over 2 squared, and then 2 over 2 cubed, right? So our ratio basically is what? Is half. Since we keep on multiplying by half, basically, right? So sorry, I hope that really makes sense. So for us to calculate the value of N anyways, what we have to do is to say Sn is equals to 1 minus R to the A in bracket 1 minus R squared Rn, and then over 1 minus R, of which from this we're given Sn as 5.8125, which is equals to okay, A, what is our A gonna be? Okay, we're gonna basically call it 3 times 2 to the exponent 1 minus 1, of which it is equals to 3, right? Yes, it is equals to 3. And then here we're gonna have our 3 and then 1 minus R to the exponent N, of which we know what is our R. Our R, as I said, our R is half, right? To the exponent N, okay? And then here we say 1 minus half. And then let's say 5.8125 times half, right? Divided by 3. Okay. This gives us 31 over 32, all equals to 1 minus half to the exponent N, right? Okay, and then from that, when we transpose -1, it becomes, the whole thing becomes 1 over 32, all equal to half to the exponent N, negative half, right? Therefore, we can say divide both sides by negative, you get positive. Half to the exponent N is equals to 1 over, we know 32 is equals to 2 basically to the exponent 5, right? Therefore, from this we know that N is equals to 5. Okay, I hope that made a lot of sense. And you see in the next example why I was saying 3 is not necessarily A. 3 is not necessarily A. If you were to substitute the first value of K, and you will see that, for example, 3 is not necessarily A, like in that one where we have where we have 24 2 to the exponent negative K. It is not the case in that one. Okay, but let's dive into it. So if the first part is K is P, and then they say write down what is the next part in terms of P. Okay, so 3.4, we are given the sum k is equals to 1, 20, 3, 2 to the exponent 1 minus k, all is equals to p, right? Of which, from these guys, what do we know from this? Basically, what this tells us is what? Okay, let me first start by writing P. We know that P is basically Sn, right? Sn is P in this case, of which you can say your A here 1 minus r to the exponent n over 1 minus r, right? Of which from that you then get your first term. Your first term in this case, it will be A. Your first term in this case, it will be 3 if you were to substitute 1 in the equation, right? And then here we have 1 minus, this one is the same as the previous question. So here is basically 1 minus half, right? All the way to the exponent n over 1 minus half, right? But then in the second part of it, now there is write down that one in terms of p. What we note that is down is what? T1 is not equals to 24. But then what is T1? T1 basically, which is A, is equals to 24 times 2 in bracket negative 1, right? That is the same as 24 over 2, which is equals to 12, right? So, okay, let's express the second equation. Expressing the second equation, we get what? We get that, okay, sum, okay, k is equals to 1, and then it ends at what? It ends at 20, and then here we had what? 24 times 2 to the exponent negative k, right? Of which this basically is equals to what? This gives us a again to the exponent a1 minus r to exponent n over 1 minus r, of which from this we get what? We get our a as 12, and then here we have 1 minus, what is our r in this case? If we were to notice that basically here again you're gonna have something like 24. Let's maybe just focus on the part that is the exponent, which is this one. Basically, this is the same as what? It is the same as 1 over 2 to the exponent k, right? Of which, even in this case, it means that your r basically is what? 1 over 2, right? So we say minus half to the exponent n over 1 minus r, né? Of which, okay, sorry, here we know we had noted our r already. This is 1 minus half, right? One thing that you'll notice here that is common is what? Let me highlight it for you. One thing that you'll notice that is common here is what? This part here, né? And this part, they are the same, right? I hope you are able to see that. Okay, so let's say let's maybe go back to this one and say or maybe to both of them is fine. 1 minus half to the exponent n, right? Over 1 minus half, for example, or 1 or over half, either way, be equal to, maybe let's let this be equals to x, ne? So therefore at the top there, therefore p is equals to, p will be what? Will be equals to 3x, for example, ne? And then we'll say therefore the sum here, this one, I won't write it in full, this one will be equals to it will be equal to, maybe let's call it y. Let's say y will be equal to 12x, right? Therefore, from this, let's try and note down what is actually y in terms of p. Okay, so for us to do that, we can cross multiply and see. So here we have 3xy all equals to 12px, right? And then let's divide by 3x, divide by 3x. We end up with what? Y is equals to 4p, right? Yeah, so anyways, therefore that one, sum of k is equals to 120, and then here we had what? 24 in bracket 2 minus k is equals to 4p. I hope that made sense, and kindly share, comments, and subscribe on any topic or question you'd like me to cover. Thank you. I will be doing functions in the next video. Kindly stay tuned.